Hey there, it's Student X, simplifying success one question at a time. And today, we're going to be tackling a cosine question from IGCSE Additional Mathematics. You'll see how amplitude, period, and the vertical shift all come together to shape the graph. Let's dive into it. So here we have the equation y is equal to 2 plus 4 cos 3 theta with this as our domain. And now the first thing to do is to compare the equation to our standard form that we have over here. Our C is what we call our vertical shift. So basically it shifts the graph either up for positive C or down for negative C. Then we have A, which is our amplitude. Now this basically determines the max and the minimum point above or below the midline, or in other words, the vertical shift C. And then we have our B, which is our frequency modifier. So this either compresses or stretches the wave horizontally. In essence, it changes how quickly the cosine or the sine wave repeats in a given period. And now using these symbols, we can easily denote that our C is equal to 2, our A is equal to 4, and our B is equal to 3. And now onto part A, write down the amplitude of y. And as stated earlier, our amplitude, or A, is simply equal to 4. And you get your 1 tick over there. And for part B, it says write down the period of y. And so the period isn't explicitly stated from the equation, but what we do know is that we can use the relationship period is equal to 360 degrees divided by b. Or we can use the formula 2 pi over b, but this is only useful in the case where our domain is in radians. But in this case, it's in degrees, so we're going to use this formula over here. And now finding our period is just equal to 360 degrees divided by our b, which is 3, gives us 120 degrees. And so our final answer, our period, or P for short, is simply equal to 120 degrees. And that's a tick over there. And on to the last question, it says, on the axis, sketch the graph of y. And now before I bring the sketch into play, what's important is that we have the 5 major points when plotting the graph. And when it comes to trig, the 5 most important points is 0, which in other words is our origin, and our P, which is divided into 4 parts. P over 4, P over 2, 3P over 4, and finally our full P, which is just 1P. So these are 5 most critical points when trying to sketch either our cosine or a sine wave onto a graph. Now all we do is that we need to find these points. So in this case, we know that 0 degrees is just 0 degrees. And our P, which we found out earlier, was 120 degrees, which leads to 120 degrees divided by 4, which is equal to 30 degrees. Secondly, we have 120 degrees divided by 2, which gives us 60 degrees. Thirdly, we have 3 multiplied by 120 degrees divided by 4, which gives us 90 degrees. And finally, we just have 120 degrees. So these are the 5 major points that we're going to use when sketching the graph. Now all that is left to do is simply plug the points into our equation. Y is equal to 2 plus 4 cos 3 theta. And all we do is that we just plug the different degrees into our theta over here. And for 0 degrees, we're going to get 6. For 30 degrees, we're going to get 2. For 60 degrees, we're going to get negative 2. For 90 degrees, we're going to get positive 2 again. And finally, for 120 degrees, we're going to get back 6. And so when I put everything together, I'm simply going to plot the points on my graph, with the x-axis being our theta and our y-axis simply being y, right? So my first point is 0, 6. My second point is 30 degrees, 2, with our 30 degrees lying somewhere over here in our 2. The third point is 60 degrees and -2. The fourth point is 90 degrees and 2, with our 90 lying in between over here. And then finally 120 degrees being 6. And since we know that the cosine is an even function, or in other words, it's symmetric about theta is equal to 0, I know that I'm just going to get a mirror image on the left hand side. So I know that for 0, I'm going to get 6 again. And I know that for -30, which lies over here, I'm going to get the same point 2. And then for -60, I'm going to get -2. And then for -90, which lies over here, I'm going to get 2. And then finally for -120 degrees, I'm going to get back 6. And when I join everything together, it should look like this on the right hand side, and it should look like this on the left hand side. And there you have it. That is our cosine graph. And just to make sure that we're on the right track, we can simply use the values that we got from earlier, where our c, which is equal to 2, which is our midline. So when I draw the midline, y is equal to 2, this is what we have, right? And now we can use this to check our amplitude. So from here, I know that I'm going to jump 1 space, 2 space, 3 spaces, and 4 spaces, right? And similarly, when I go down, I'm going to jump 1 space, 2 space, 3 space, and 4 space, right? And I stop as soon as I hit my maximum. Likewise, on the bottom, I stop as soon as I hit my minimum. As you can see that our minimum lies over here. So that's how you know that, okay, my midline is correct. My amplitude of 4 is also correct. And lastly, to check to make sure that your period is correct is simply to look at how many oscillations are completed in one 120 degree cycle, right? And in this case, one oscillation is simply one wave, right? So from 0 up until 120, our start point is at this point over here, and our end point is at this point over here. So once you know that the start and the end points are on the same level, then you know that it's been one complete oscillation within the given period. Likewise, when you look at the left-hand side, we have -120 degrees with 0, which is still 120 degrees in length. My start point is over here, and my end point is over here, right? And we can see that they're also both on the same level within the same degree length. And that's it. One graph fully decoded. If this helped, hit the like button, subscribe for more IGCSE Add Mathematics questions, and see you in the next video with me, Tutor Nax, simplifying success one question at a time.